Okay, hi everybody. My name is Ghinwa Choueiter. I'm a data scientist and machine learning engineer at DataZoo. So I'm going to be giving a lightning tutorial on pandas. For those of you who were at the PyData conference last weekend, hopefully they attended the multiple pandas tutorial, hopefully this will still give you a concise summary of what you learned over the weekend. So pandas basically are a Python library for data analysis. They were developed starting in 2008 by Wes McKinney due to his need for a tool for financial analyses. The end result was luckily a much more powerful tool that is a library basically that is rich in data structures and routines that we can use for data manipulation and analysis. The two main data structures in pandas are series, which is a one-dimensional labeled array. You can think of it as a dictionary or a NumPy array, but it is quite a powerful structure. And the labels of the array are known as the indices, the index of that series. The second most common data structure, which I personally use more often, is the data frame. It's a two-dimensional labeled data structure where both the columns and the rows are labeled. And again, the labels of the rows are known as the indices, the index of the data frame. So in this tutorial, I'm going to be focusing on the data frames rather than the series, although they're equally powerful. And I'm going to make up some of my own data to illustrate examples and also use the MovieLens 1 million data set, which is a data set of 1 million user ratings of movies. If you're interested, I can also send later on the gist link for this presentation. So what I'm going to talk about are 5 easy things you can do with pandas. First, it's easy to load and create tabular data with pandas. It's also easy to access that data once you've created it. If you're working with real-life data, you're probably going to have missing data. It's easy to handle missing data with pandas. And then fourth, it's easy to align your data. And finally, it's easy to do all kinds of grouping and data transformations with pandas. So the first example is a simple one related to how easy it is to load tabular data with pandas. So first of all, this is how you would import. And then what I'm going to do here is a simple example of creating a data frame from a dictionary structure. So here I have a dictionary where there's fruits and calories. And once you wrap this dictionary with data frame, what you're going to end up with is a table that contains 2 columns, the calories and the fruits. So, and this is basically from the keys of the dictionary. And because you did not specify the index, which is what are the labels of your rows, a data frame will by default assign integers starting from 0 onwards for your data frame. More commonly, you would create data frames from file. So you could create them from CSV, from JSONs. In this case, I'm loading the data that constitutes the 1 million data set, which is 3 tables: the users, the ratings, and the movies. So the way I'm doing that is using read table function. The read table function will, of course, take the input file that you want to read. It also takes the separator, which in this case are 2 columns. And then I specify that the header is none because this file has no header. Otherwise, it'll take the first row as the header. And then I'm specifying the names of the columns, which I, again, know in advance. So once I do that, and I do that for the other tables as well, if you do users column 5 using the slicing notation, should be common for you from NumPy array. You will get the first 5 rows from the users table. So basically, that was a very straightforward way to upload or to load your data in tabular format, and it's equally easy to do it for CSV. There's a very fast read CSV function that will do that. Notice that those 3 tables, users and ratings, share a column which is user ID. So every rating is associated with a user, and every rating is also associated with a movie. So just looking ahead, we might want to merge these three tables to create one big table of aggregate information. So second, we have the data, so now how do I access it? A typical way to access the columns is either using the dot notation. So in this case, if I want to access the user ID column in tables users, I would just say users.user ID. You could equally use this commented method, just using the bracket notation, which is a bit more convenient to use when you want to select more than one column. So here I'm selecting both the user ID and the gender columns from the table's users. And again, just for convenience, I'm only looking at the first 5 rows. That was for columns. Now, if I want to access, the data by rows, I would use the IX function. The IX function is very easy to use. You can either just give it one number, which is the number of the row you want to access. You can give it a slicing notation. You can tell it, I want from this row to this row. You can, if your data frame is, has labels of strings, so it's not 0, 1, 2 is, for example, ABC, or names of people, your index is the names of people, you can even do that. You can say users.ix, Andy, column, Tom. And you will get all the rows between those names. You can also use IX using masks and filters, as in this example over here, to, for example, pick all the users whose age is more than 25. So this will give you all the rows of the users whose age is more than 25. So now you have the data, and maybe you have missing information in it. To illustrate, I created a sample data frame, and I fake inserted some nans in it. So this data frame has 7 rows and 4 columns. And notice that column 4 is all nans. And the others, except for column 1, also have nans in them. So one thing to note is, for example, if you want to use any of these statistical routines already available for data frames, like function describe, which is similar to summary in R, for those of you familiar with R, function describe will give you the descriptive statistics by column of that data frame. And by default, it will ignore the nans. Unless all your column is nans, of course, there's nothing it can do about it. But like for column 2, it just looked at the 2 rows that had any data in it. If you want to drop your nans, you don't want to handle them, you can use dropna. By default, dropna will cancel any row that has any nans in it. If you don't want to do that, you want to cancel or remove columns, then you can specify that using the access argument of dropna. So by default, access is 0. If you say 1, it will remove columns. And if you also tell it, I want you to remove it if all of them are nan, not if any of them. Like, don't be so, don't just remove everything. So if you say how equals all, access equals 1, in this case, it will remove by column if it's all nans. So in this case, it got rid of column 4. If you don't want to get rid of them, but you want to fill your nans with something else, like 0 or the mean or the median, you can use fillna. In this case, I filled every column by the mean of that column. And then there are many other functionalities that you can use to basically propagate values into nans forward or backward. Fourth, it's very easy to align the data. So going back to the movie example, I mentioned that the 3 tables kind of shared columns. So, and we could possibly merge them, and that's exactly what I do in this command. So using the function merge, I first merge table ratings and users on the column user ID, and then I merge the result on the column movie ID, and the result is the million data set that I mentioned at the beginning. Merge by default is done in inner mode. That means it intersects. So let me show you an example here. I create 2 data frames. One has the fruit and its color, and the other one has the fruit and its calories. Notice that plum is not in the second data frame. So when I merge the 2 data frames on fruit, plum is not in the result because it's not in one of them. If I merge, however, with the argument how being outer, not inner, that means it will union everything. Plum will be there with an and because it doesn't have the calories. Finally, it's easy to group data and do all kinds of data manipulation on the result. Let's say here I want to get the mean of the rating of every movie by gender. So what I do is I group by gender and title, so you can group by as many columns as you need. I picked out the ratings column from it, and then I applied the statistical method mean, which is already available on the result. So the result is basically the mean of every movie by gender, which is what you're seeing here. You can do more powerful manipulations. You can create your own functions and do all kinds of transformations on the grouped results using the function apply. So here, let's say I want to get the z-score of the ratings, again by gender. I create my own function. It's a simple function. It can be much more complicated. It takes the group, it subtracts the mean, and divides by standard deviation. So basically, it takes a group and gives back a group, returns a group. And here, I do the same thing. I group by, I take the rating, and then I use dot apply, and I put the function in there. And again, that's exactly what happened. We basically got the z-score of the ratings by gender for every title. It's a little bit warped or complicated, but once you've played with it a little bit, it'll make sense. So, and over here, I have also another just link that I can also email to everybody on. I was trying to play around with different group by functions because there's quite a few with Pandas. So I'll send it at the end. So that's it. Thank you.
Any questions? We have time for one question.
Yeah.
Is there a performance advantage to apply versus just iterating over
Yes, definitely. Apply is, because I've tried it myself when I didn't know about apply. It's much faster. It's optimized. To do that, it basically literally takes the data frame, splits it, applies, and combines. So it does all that in one. So you definitely want to use that versus iterating over the groups.
Even when the function is just Python, is
Oh, if it already exists like mean, in the previous example, I just did group by mean. So you can just apply, like, you don't even need the function apply. You just use that function itself. But no, I would not iterate over the groups.
So this has kind of a SQL flavor to it, doesn't it?
Yes,
Yeah.
yes,
Okay.
definitely.
Thank you.